All right, so today is all about hyperbolas. The last conic section, the one we didn't get to last time. What? How? What? Oh, okay. We're going to make two pictures because, like ellipses, hyperbolas come in two flavors, horizontal ones and vertical ones. I'm going to make them big because we have to label lots of moving pieces. Of the four conic sections, hyperbolas are going to graphically look the most scary, but in terms of their equation and drawing them, they really aren't much different than ellipses. So this first part is going to look intimidating. I want you to kind of stick with me because when we start doing examples, it's very similar to ellipses. It's not as scary as the picture will lead you to believe. Okay, so two flavors. We have horizontal ones and we have vertical ones. And that label has to do with the main axis that cuts our hyperbola in half. So horizontal, the main axis, also known as the transverse axis, that cuts our parabola in half is this way, and our circles go, or our curves go this way. And I'm going to do my best to draw that without looking too messy. It is a weird one. So the x-axis is our transverse axis, and it cuts the curves through their vertexes, or vertices. And then horizontal, or vertical rather, is the other way. So it's going to come like this. And again, please don't judge me. I majored in math and physics and not art for a reason. I know I can't draw. I am going to color code this because we are about to label several moving pieces. So you will want the markers at your table. I will start with familiar pieces. These guys should have a vertex, just like parabolas have a vertex. Because parabolas always come in a pair of curves, they will have a pair of vertices. And I am going to come back and fix this picture because I didn't draw it very well. Better. The center of the hyperbola should be halfway between the vertices. These curves kind of look like parabolas, and there is one more point that they have in common that parabolas also have, and that is called the focus. And remember that that occurs a little bit inside of that curve. unlike all of the other shapes that we've drawn for conic sections, these guys have asymptotes. There's two asymptotes. And those two asymptotes form an X that bounds that curve. And generally, when I want to draw a hyperbola, if I know where the vertices are and I know how big the box is, drawing the curve is pretty easy. I draw those diagonals and the curve starts at the vertex and goes out along the asymptotes. It's actually less scary to draw than a lot of our other curves. So now I'm going to draw something a little weird. Bear with me. I am going to draw a box in that picture. Yes, Gerardo. The focus, remember like the parabola, when I had a parabola yesterday and I had the directrix and I had the focus and the shape was defined by any point has the same distance from the focus that it does from the directrix? Hyperbolas have a similar definition, except it's looking at the distance between any point on the curve. That was the P for the parabola. Here it's a little different in that any point on the curve, the distance from each of the foci, the sum of those two numbers should be the same for every point on the curve. So if I were to add those two orange distances together, I'd get the same number regardless of where I am on the curve. Because as one gets, or not the sum, the difference, sorry. The difference between the two. Oh. Okay. So the focus is that point that creates the shape. We're defining points from it. We're not going to do math with it, but we need it to find where the asymptotes are. For us, we're going to use it to find the asymptotes, which is the next point. So hyperbolas will always form a box in between them. The box helps us draw the asymptotes. The box extends from the vertex out to the asymptotes. And then across. Well, again, this is the weird part. It looks scary. Once we do it, it'll be less scary. And that's true of every hyperbola. So I can do it for my vertical guy too, and I should get a similar pattern. Out to the asymptotes forms a box. Assuming I could draw, which I can't. And we see 2 points on the box. I see my vertices in red touch the box. The 2 points on the other axis the non-transverse axis. Those are called a co-vertex. Co. The vertexes and the co-vertexes form a box. The diagonals of that box form my asymptotes. The points that form the edge of that box, the orange points, are the co-vertex. So that is a co-vertex. That point is a covertex. The box connects the vertices and the covertices. Deep breath. There are 3 distances that are buried in that hyperbola that we're going to need to graph and write equations. And they come from the vertex, the focus, and the covertex. Those are our big points. So it's this guy, and this guy relative to the center. We get 3 distances. I'm running out of colors. So the first distance is from the center to the vertex. And we're going to call that A. So A is center to vertex. Yeah, no, these are complicated. These get their own day. But again, once we've got the picture labeled, the actual math is a lot less scary than it looks. My 4th period got through it with a couple minutes to spare. Yes, Bruno? We'll get there in a minute. I have 2 more letters to define first. Next one, I need the other direction for the box. So I have center to vertex. My next letter B is center to covertex. So I've got center to vertex is A, center to covertex is B. The last point of interest is my focus. So center to focus is called C. In graphs, when you are asked to write an equation from a graph, most often you will be given the vertexes, the vertices, and the focus, or the foci. They do not usually give you the covertex, because the covertex doesn't directly have anything to do with the curve. But the covertex is the piece that shows up in the equation. So I need a relationship between A, B, and C, because the graph will give me A and C. What I actually want is A and B for the equation. And the upside is that you already have a formula for that. The relationship between A, B, and C is Pythagorean's theorem, which is what? B squared equals C squared, yeah. So those 3 numbers follow that relationship. If you have 2 of them, you can find the 3rd. If you start with an equation, you'll have A and B, you can find C. If you start with a graph, you'll have A and C, you can find B. Deep breath. I'm going to give you, yes. Yes, did you make U-Haul? Yeah, perfect. I'm going to give you the standard form equations, and then we're going to practice moving between equations and graphs back and forth. Yeah? I hear whining in that back corner, frowny face. Frowny face. Happy thoughts, Gerardo, happy thoughts. Okay, here we go. Up, up. Yes, Bruno. When we're graphing it, do we get to graph all those little symbols or no? No. I will show you what I want when you graph in a minute. Yes, they do. All right, so I mentioned when we started this, that these guys are similar to ellipses. That shows up in their equations. What does the equation of an ellipse look like? Parentheses. What else? Fractions. Good. A squared b squared equals what? 1. Good. The only difference between an ellipse and a hyperbola is that it's not addition in between them. It is subtraction. Nope. Subtraction. Ellipses are addition. Hyperbolas are subtraction. Their equations are otherwise identical. Yes, Bruno? Because these guys are symmetric about their axis, when we flip them, you get the same curve. So no, we don't have that happy face, frowny face issue. Yeah. No. Oh, you mean that when we pull out H and K? Yeah, that's the pattern for all translations. Yeah. But then now the other one is correct. There's already subtraction there. Good. So when I take something that's horizontal and I rotate it so that it's vertical, what happens to X and Y? They flip. Perfect. And that's exactly what's going to happen here. So instead of X in front, vertical guys have Y in front. So the variable in front tells you the direction of the main axis, also known as the transverse axis, the axis that cuts the curves in half. We know that H and K are my center. We know that A tells me how far my vertex is from the center. I know that B tells me how far my covertex is from the center. And once I have my vertices and covertices plotted, I make the box, I draw my asymptotes, I draw the curves. It's way less scary than it sounds. We're going to do 2 examples of going from equation to graph, then we'll see an example of going from graph to equation. Okay. Deep breath, here we go. Well, right faster. You don't have one for me. Did you make it out to another teacher? Then just go. There's already one there, just go. All right. Example. Whoops. We want to graph x minus 2 squared over 36 minus y plus 5 squared over 81 equals 1. Ellie, how do I know that that's plotting a hyperbola? Very good. Both variables are squared, a subtraction in between them. Perfect. So I know it's a hyperbola. Like ellipses, I need 3 numbers. I need my center coordinates. I need A, I need B. I also need to know if this is a horizontal hyperbola or a vertical hyperbola. Who can tell me? How do you know it's a vertical hyperbola? If the x is first, is x the vertical axis? X is the horizontal axis. This guy is a horizontal hyperbola. X is first. This is horizontal. So my vertices sit on the x-axis. My co-vertices sit on the y. All right. So center. H and K. H comes from the x term. K comes from the y term. We change their sign. So my x coordinate is 2. My y coordinate is -5. H and K. H and K. H and K. My A, I know that A comes from the first term, and it's the square root. So I need the square root of 36, which is 6. That's where my vertices are. 6 in either direction from the center. My co-vertices, I need the square root of 81, which is 9. They're going to be 9 from the center up and down. Good. Yes, Ellie. So these follow the same transformation rules as all of the other transformations we've done in pre-calc. So anytime something's coupled with the variable in parentheses, when you pull it out from the equation, it changes sign. Yeah. We saw that with translations like way back in unit, I think 2 and 3. So we need to graph. Let's get a coordinate plane running here. So I'm going to draw the center first because A and B are measured from the center. Where is my center? 2, -5. So over 2, down 1, 2, 3, 4, 5. There is my center. I'm marking it in red because my center is not actually on the curve. It's just a guide point. My back table is way too noisy in the middle of a lecture. This is direct instruction, not singing time. We can sing when we're done. Because this is horizontal, A is side to side. So I'm going to go 6 to the left and 6 to the right. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Those are my vertices. Those points actually sit on the curve. Those are the butts of the curves. Yes, Julie? That's the center, right? 2, -5. So the dot in the middle is the center, and then I've got my vertices on either side of the center 6 away. Next, I need the co-vertices. If my graph is horizontal, the co-vertices are vertical, and my co-vertex number is 9, 9 from the center. So I'm going to go 9 up from the middle, 9 down from the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Make it a weird looking cross. And from that cross, I'm going to make a box, because those 4 points on the outside edges are the centers of those sides of the box. It is a long box because it's 18 down, right? 9 up and 9 down. That's 18 total. It's a long, it is a rectangle. Sometimes they're squares, sometimes they're rectangles. It's always going to be one of those two. Good. Remember that the diagonals of the box are my asymptotes. Once I have vertices and asymptotes, I have my curve. I'm almost done. So I just need to draw the diagonals of those boxes. I am going to cheat and use the computer to help me because I cannot draw for poo. Please do not judge me. So diagonal. Bless you. So one diagonal, and I need the other diagonal. Yes, you do have a ruler. I have technology, you have a ruler. You can also make these nice and straight. You have graph paper and a ruler. You can be neat too. Ah, no. What the heck happened there? Honey face. No, stop doing that, for goodness sakes. Just trying my patience here. Why does this thing not like me? There we go. Shh. The curve. I start at the vertices and then I trace the curve out towards the asymptotes. Because this is horizontal, the points on the left and right sides are the butts of my curve. Those are my vertices. I'm going to start at the vertex in a nice smooth curve out towards the asymptote. And these are going to be low and flat because this is a wide curve. Wait a minute, how is that not going to do this? What? How is that not going to do this? Don't worry about that right now. Focus on the lesson first. One thing at a time. We're going to do one more. So I want to make sure we know how to do this. And some of us are clearly not paying attention, so I'm going to do it again to make sure that we get it. Some of us have checked out and it's not quite time. All right, one more. I'm going to have you guys help me. Since we've done one, you should know what you're doing now. Oops, that's not what I So we want to plot y minus 1 squared over 9 minus x squared over 4 equals 1. So first thing I need my center, I need my A, I need my B. I need to know which axis this shape sits on. I need to know what shape it is. Megan, what shape does this equation make? What are we talking about today? Hyperbolas, very good. How do you know it makes a hyperbola? What in the equation tells us hyperbola? Fraction and the sign, the subtraction in the middle. Good. Because ellipses and hyperbolas have fractions. Ellipses are plus, hyperbolas are minus. So we know this is a hyperbola. Much like ellipses, I need to know my axis. I need to know my center, my A, and my B. So, Aubrey, is this a horizontal hyperbola or a vertical hyperbola? This is vertical. Very good. How did you know it was vertical? Excellent. The variable that's in front started with a y must be vertical. That means that A is coming from my y term and B is coming from my x term. Because A is always the number in front, regardless of what variable's there. So A is going to go up and down, B is going to go side to side. All right, show of hands, who can tell me where my center is? Yes, Gerardo. 1, 0. Can I get a thumbs up if you agree? I see thumbs up and nodding. Very good. Pull the numbers out, change the sign. X was missing a number. Perfect. Next, I need to know what my A is. Brandy, what is my A? 3. Very good. Square root of 9. Perfect. Lucero, what is my B? 2. Perfect. Square root of 4. A is square root of first number. B is square root of second number. Perfect. I now have enough information to graph my hyperbola, right? Same basic information as a parabola, or a ellipse, sorry. Yes, that is exactly why we did an ellipse as a warm-up, because they are related. Nope. I very rarely do things random. There's usually intent there. Okay. Gabe, what goes on my graph first? The center. Very good. All of my points are measured relative to the center. 1, 0. Perfect. Alan, what goes on my graph next? The A and the B, good. And A is attached to Y. So A is up and down, B is side to side. So for A, I'm going to go up 3 and down 3. For B, because it's attached to X, I'm going to go left 2 and right 2. Very good. Julie, what comes next? We have to do the box. Very good. I need the box to figure out where my asymptotes are. Once I have my box, my asymptotes are the diagonals of the box. The next question is, where do my curves go? To the left and right, or the top and the bottom? Top and bottom. Very good, because this is a vertical hyperbola. So my vertices are top and bottom. Start at the vertex, smooth curve out towards the asymptotes. You'll notice with the hyperbolas, because of those asymptotes, the edges of the graph are a lot more flat than parabolas are. Parabolas curve and continue to get steeper and steeper, whereas these guys eventually flatten out along the line. So when I said that parabolas were narrower than hyperbolas, that's what I was talking about. Aha, makes sense now. Good. Okay, we got time for one more example. I want to practice going backwards because Delta Math may ask you to do that. So if I give you a graph, how do I figure out the equation? Stop whining. You guys are such whiners. It's only first semester. You can't have senioritis till after you've gotten all of your acceptance letters. There's the time limit. And now that you brought up senioritis advice from somebody who's been down this road, they do revoke acceptance letters. So if you totally like jump the rails during second semester and fail all your classes, they will absolutely call you back and say, no, we don't want you because you couldn't keep your act together. There's an expectation that even if you're not like going on all cylinders, you haven't totally checked out either. Yeah. Yeah, you also have to get enough units to graduate. So if like you fail all your classes, you don't have enough units to graduate, congratulations, you're a super senior, which would make me very sad. So please do not be a super senior. All right, we've got a picture of a hyperbola. How do I know it's a hyperbola? It's double, good. Hyperbolas are the ones that have pairs of curves. And I'm given the vertices, a vertex at +3, a vertex at -3. I'm given the foci, a focus at +5, a focus at -5. I need the same information that I use to graph it as I do to write the equation. So I need to find my center, I need to find A, I need to find B. So we will start with the part that's probably a little less scary. I know my center is halfway between my vertices. Where is that on my graph? 0, yeah, right smack at the origin. So the coordinates of my center are 0, 0. I know that A is the distance from the center to a vertex. How far are my vertices from my center? Vertex? Where's my vertex? It's not at 5. It's 3. Vertex is the butt of the curve. It's actually on the curve. So that's a vertex, that's a vertex. And I agree with Louise. So it should be 3. 3 in front, 3 behind. You are right, Gerardo, in that I do need to know where the focus is, and that the focus is 5 from the center. The question is what label goes with that 5? C, very good. In my equation, I don't want C. Oh no, I was right. And the question is, how do you know that B is 4? So for those who didn't do the math in their head, remember A, B, and C follow the Pythagorean theorem. A squared plus B squared equals C squared. So 9 plus B squared equals 25. That's where that math came from. Subtract the 9 from both sides, which is where the 16 came from. Square root of 16 is 4. Very good. That's the last thing that we needed. Now I just plug the numbers in. H is what? 0. K is 0. Very good. So this is x squared and y squared. And in bottom, I want the squares. So 3 squared is 9. And you're right. 4 squared is 16. How did I know that x should go in front? Very good. It's a horizontal hyperbola. Very good. Congratulations. You have successfully survived pre-calculus. That was it. We are done. Next week is review. Friday is your final. Yay!